Hello everyone. Here is a question of the day, day 3, topic SHM. Let's first read the question. The arrangement of two identical springs and a block kept on a smooth surface is shown. Initially, both the springs are at their natural lengths. If a free end of the right spring is moved with a uniform velocity v towards right, then find the displacement covered by the block till it acquires velocity v. Spring constant of both the springs is K and mass of the block is small m. So what is given to us? Two springs are there which are identical and initially at natural length with a block. Block is kept on a smooth surface, right? Free end of the spring you are moving with constant velocity v. By that, what is happening? Block is also moving. We need to find displacement covered by the block till it acquires velocity v. So that is the question. Till it acquires velocity v, how much is the displacement of block that is required? So as I said, it is a very good question. If you are giving yourself 4 to 5 minutes for this question, then also it's all right, no problem. So give that time to you, right? And try this question by your own. Pause this video and then we'll discuss the solution of it. Okay. So I think all students have tried. Let's see the solution part of it. First of all, we need to decide our approach. So what should be the approach of the question? By just roughly looking at the system, I can think like block is performing SHM, right? That is coming to my mind that two springs are there, block is here, and the block might be performing SHM. So it means again I can think there are two separate approaches, force method and energy method. But if I'll carefully think, we are maintaining constant velocity of a free end, and that free end is what associated with a spring. Spring is going to extend with time, its extension is changing. So obviously, to move free end with a constant velocity, I have to apply force. I have to apply force. It means I'm doing work also. So since I'm doing work on this system, with respect to ground, this system cannot perform as jam, right? But still, we have to think around force method so that we can write force equation on it. We can obtain one equation of force in terms of its displacement, so that we can get idea of how the block is moving, right? So I will go for force method and I will try to write equation. I will try to write force equation. So my brainstorming angle should be towards writing force equation in terms of displacement covered by the block. So that should be my brainstorming angle, right? So as I explained, force method we have to apply, means force method means we should try to write force equation. Energy method we are not using. Okay, so brainstorming angle. So now see what I have written, all those quantities. X is a displacement of mass m, right? So displacement of mass m is x at any instant. It means extension in spring 1 is also x. Spring force acting on m due to spring 1 is kx towards left, and due to spring 2 will be what? K into x dash, where x dash is extension of spring 2. So what will be extension of spring 2? Displacement of a free end minus displacement of block. So means Vt minus x. So that is what? Extension of spring 2. So it means net force on the block we can write in this manner: minus kx plus k into Vt minus x, means any force towards left negative, towards right positive, like that I am writing. So I am getting this kind of equation. So this kind of equation we can say with respect to ground I am writing displacement of block M. So as I said, just by it's what is given in the question that we have to apply force to maintain velocity. As I said, it cannot perform SHM, and by force method also we have verified that with respect to ground block cannot perform SHM, right? Okay, so but again we can write A as d square x by dt square, V as dx by dt, so it will be a differential equation. So some strong mathematics required here, right? So for King, or you can say Manasa, some of my good students in maths, so it's not a big task. But for ordinary students like me who are not that good in mathematics, so it will be a very lengthy thing. So what to do? We need to think about something out of the box, which obviously is our crux point. So what is crux point here? So there are some systems which are not performing SHM with respect to ground, but those systems can perform SHM with respect to some moving frame. So that is our crux point of the question, right? So here this system is not performing SHM with respect to ground, but if I will slightly modify this equation, this can perform SHM with respect to some moving frame. Just like in our double block spring system, in double block spring system, the blocks does not perform SHM with respect to ground, but those blocks perform SHM with respect to center of mass, right? So center of mass can be moving or stationary, okay, that is another thing. But yes, these blocks can perform SHM with respect to a moving frame, right? So same thing is applicable here also. So that is our crux point, the most valuable point of the question, right? So that we need to keep in our mind. So now I am trying to modify the equation, right? So now here modification also we are doing in a very beautiful manner. So first I am writing the equations taking 2k outside. So now mathematically d square x by dt square is the same as d square x minus vt by 2, because this vt by 2 is a linear function. If you do derivative of this function two times, again derivative of this function two times, or derivative of this two times, it's the same thing, derivative of x two times, same thing. So I can replace d square x by dt square with a double derivative of x minus vt by 2, this function, right? So by rearranging in this manner, this equation is looking very good. It means this variable x minus vt by 2, that is performing SHM. So x minus vt by 2 performing SHM means what, beta? It means the block is performing SHM with respect to a moving frame, right? A moving frame which is moving towards right with the velocity v by 2. So any frame which is moving with velocity v by 2 towards right, with respect to that frame, our block is performing SHM. And from equation omega, what you are getting? Under root 2k by m. So block is performing SHM with respect to an observer which is moving with speed v by 2 towards right. So now initial and final condition, if you see, now final condition means what? In the question they said final velocity of the block should be v towards the right, and our frame of reference is moving with the constant speed of v by 2 towards right. It means initially block which is at rest with respect to ground is moving with velocity v by 2 with respect to our frame of reference, and finally since its velocity is v towards right, it means finally it should move with the speed v by 2 with respect to our moving frame, right? So that is the concept. Now initially what are the forces acting on block with respect to our new frame? Springs are at natural length, no spring force, and our frame of reference is also inertial frame of reference, right? So inertial frame of reference means a pseudo force 0. So no problem in that also. It means initially location of the block is mean position with respect to our new frame of reference. And from velocity profile, we can see final position is also mean position, because initial speed with respect to our new frame of reference v by 2 towards left, final it is v by 2. It means it has completed half oscillation of SHM with respect to our new frame of reference, right? So it means the time taken should be what? It should be half of the time period. It means from initial to final position, time taken is t by 2. So that is time taken by t by 2. So that is the time taken. Now displacement of block with respect to new frame is 0, because again it has returned to mean position, right? So it means with respect to new frame of reference, displacement of the block is 0. So displacement of the block I am writing now with the mathematical equation, displacement of the block with respect to frame plus displacement of frame. So now displacement of block is equal to displacement of frame, because of block with respect to frame, this part is what? 0, right? So first term is 0. Now displacement of frame is moving with the constant speed of v by 2, and in what time it is moving? It is moving for time t by 2. So v by 2 into t by 2. So we are getting this as our answer. So that is our answer. So that is a question, full question, a very good question. Again, this video you can see again to fully understand the concept behind this question, right? Okay, thank you students.